Hey everybody, this is Mr. Bells here, and I'm going to give you a little bit of a video here on some statistics. This is our unit, I guess our fifth one that we're going to cover in data analysis. It depends on the year though. Introduction to statistics today, mean, median, mode, range, and something called standard deviation, which is what we're going to lead into, pretty important for the information that's coming at you. So here we go. Make sure you have your graphing calculators ready. We're going to do some stuff on that too. Okay. So we're going to start with talking about these things. So we need some data first. So let's go. I'm going to do some small data. So we'll go 12, 20, 30, 32, and 36. So we've got those 5 data points, and we could have 100 data points. It's not going to change what's going on. But we're going to talk about these 5 things given these 5 data points: mean, median, mode, range, and standard deviation. Most of you have heard of the first 4. Standard deviation right here might be different. I'll spell it out for you here too. Standard deviation. Standard deviation allows us to be able to do some things with something called z-scores, which allows us to compare groups that maybe weren't as easily to compare before, like an SAT score to an ACT score, how 2 completely different tests, how we can match that up. Or if somebody was running a decathlon, how to be able to put a high jump score and a mile run score together, compare those 2 things to how they do against everybody else. Okay, so let's start with the first thing. So in order to be able to do a mean also known as x bar, x with a bar over the top of it, also known as the average, simply takes those 5 numbers, adds them up, and divides by how many there are. So if we go to our handy dandy calculator here, and I do that, I can do 12 plus 20 plus 30 plus 32 plus 36, hit enter. I get a total of 130, and I simply divide that by how many numbers there are, n, in this case 5, so 130 divided by 5 gets me an x bar of 26. Okay, so you can see that the average of 26 is kind of pulled down a little bit because we've got this one number here that's a 12. Okay, and we're going to talk about those types of numbers too, because you can see that our middle number here is 30, and that's the next thing I'm going to talk about. So a median is the number that's in the middle, but you can't just say it's in the middle from a list. It has to be in the middle if it's ranked from low to high or high to low. Okay, so what I need to be able to do right now on this is find the middle. So low one, high one, low one, high one. This one's right here in the middle. So 30. So that's what's considered the median. I'm going to put that over here. So the median is the one that's right in the middle. And lots of times that's a good way to be able to judge a data set, is by what score is right in the middle. Because again, an average can be what we'll say skewed a little bit because of a specific thing that's really low, or a specific thing that might be really high. In this case 36 isn't that much higher, but a number that might be lower that would skew that score. Like for instance, if I was to look at everybody in the classroom and I'd look at all their ages and then put my age in there, my age would be considered something called an outlier. It would kind of skew those scores. Okay, so mode is the number that occurs the most, and you can see that none of these numbers repeat. So there's nothing here that's a mode, and you can have one mode, you can have more than one mode. Where would we consider modes important? Let's say that we were selling cars at a car dealership. Well, the mode might be the vehicle that sells the most, and that would be something that's important to us, because we'd want to know, hey, we need to get that back in stock, right? or if we had a concession stand and we were selling hot dogs more than anything else, or cold night, hot chocolate. Those are the things that we're going to be like, hey, that mode is important because we need to replenish it. Okay. Range is the highest minus the lowest. So if I'm looking at tests in my class, I would hope that my range would be really low, which means the difference between the highest score and the lowest score, there isn't that much spread. Unfortunately, sometimes there is, for two reasons. Sometimes I get students that are doing extremely well and get a really high score. And unfortunately, I also get some students that maybe aren't doing as well, whether or not that's because the material is really hard for them or because they just haven't put in the time or effort to be able to do that. So in this case, our range right over here would be 36 minus 12, or 24. And again, that's from the highest score minus the lowest score, and that's my range. Okay? So why do I have something called a standard deviation at all? Well, a standard deviation basically takes a look at each one of these numbers and says, how far away are they, right, from what we're going to consider the average. Okay? So the first thing I do to develop this number, and this is an actual number, standard deviation is a number, and it measures so standard deviation measures the spread of the data. So how far out the data is spread from the mean, okay? And they try and get it down to a specific number, okay? So what I'm going to start with is this. There's quite a process to this. So I'm going to put down all the numbers, 12, 20, 30, 32, and 36. And we're going to look at it in terms of the mean. And the mean, we said right over here, was 26, right? So the mean is 26. So I'm going to put 26 here and compare it to each one of these numbers, okay? So this one, the 12, is 14 below it. The 20 is 6 below it. The 30 is 4 above it, positive. The 32 is 6 above it. And the 36 is 10 above it. And you can see if I add up all these things, 14 and 6 is negative 20, and then 4 and 6 is 10, and 10 is 20, that if I add all those up, it equals 0. So what I really can't do is I can't just add them all up, because since we're measuring them compared to the average, it's always going to be 0, okay? So what we are going to do, though, is we're going to take each of these numbers, and there are two different ways to look at them. One, we could take their absolute values, and that would be a 14, a 6, a 4, a 6, and a 10, and just look at those numbers. The other way we could look at it is take those differences and we could square them. And that's how standard deviation works, is we're going to square those differences. So I'm going to start with the first one, and here we go. So 14 squared, enter, it's 196. Now I did that because if you put in negative 14 and square it without putting in parentheses, you're not going to get 196, right? Watch, negative 14 squared. It's going to say negative 196. You got to make sure you put it in parentheses, because you know a negative times a negative is always a positive. So again, we've got to get that positive. So this number is 196. This number is 36. This number is 16. This number is 36. And this number is 100. Okay? So again, this is the squares of the differences between the average and the original scores. So I'm going to add up all of those numbers. 196, 36, 16, 36, and 100. 196 plus 36 plus 16 plus 36 plus 100. Just like that. And I get 384. And I'm going to divide that by 5 to find the mean of the differences squared. Okay, so I divide that by 5 and I get 76.8. You're like, ooh, is that the number I want? Is that my standard deviation? Well, what we did before back here, we squared them to make sure everything was positive. So what we have to do now is we have to square root that. So I'm going to go ahead and second square root second answer like that. And you're going to see I'm going to get 8.76. So the standard deviation is actually 8.76. And you're like, ooh, okay, so how is that beneficial to us? Well, big picture, if we want the spread of the data to be really small, we're looking for a really small standard deviation. We don't want a lot of spread or change in it. For instance, maybe I'm making a bolt, right? I'm machine operating this bolt with these threads, and it has to be a certain weight and a certain length. Well, we would want the weights of all of these bolts, the differences in them, to be really small, right? We don't want to have a big change in the weights of these bolts. We also want the lengths probably to be within, I don't know, like a 1/64th of an inch. When we're making these things, they have to be really tiny things. So we want the standard deviations of these things to be really small. Now, when I'm comparing things, it definitely makes a difference on it. Like I could have a room full of people, and look at their ages, and their standard deviation could be, say, 4.6. And then I could say that the weight, W-E-I-G-H-T, the weight of, say, 10 bananas has a standard deviation of, let's go 1.3 ounces. Well, just because this 4.6 is a bigger number than this 1.3, it doesn't mean that the standard deviation is spread out now. In terms of ounces, most ounces for bananas are probably going to be between like 5 and 13, where ages of people in a room could be between 0 and maybe all the way up to 100. So we really have to look at the spread in the types of numbers before we look at whether or not this standard deviation is better than this standard deviation. So again, it really makes you have to look at what it is that the number is. However, if we were saying the standard deviation for one offensive line for a football team and the standard deviation for another offensive line for another high school football team, both of them being high school football teams, then we could say, hey, this one's definitely bigger than another one, because they should be comparable. Okay? Now, I've done a whole lot of things right now, data-wise, and I'm going to show you that everything that I just did, we can get on this thing. Okay? So, turn your calculator on, and I'm going to go slow through this, because a lot of you haven't done enough stuff with stats on your calculator. We're going to go ahead and hit clear. And I'm going to try and show you the buttons and the screen at the same time. Hopefully this is good for you. So in order to do a lot of our statistics, and the calculator can do a lot with it, we're going to go ahead and hit our stat button and then enter for edit. These different columns right here, L1 through L6 or whatever it is, allow us to put data points in. Well, if I was plotting points on a graph, I would use an L1 and an L2. But right now, our data set is only one thing. So we're going to put all of this in L1. So I'm going to go over here to L2. I'm going to up arrow here, and I'm going to hit clear. I'm not going to hit delete. I'm going to hit clear and enter. And that allowed me to clear out those data points. Another thing that you can do is you can hit second and the plus sign. And number 4 right here says clear out all your lists. So I'm going to hit number 4 and I'm going to hit enter, and that should clear out everything that's in my lists for stats. Okay. So I just hit clear on my home screen, and I'm going to hit stat and edit, and now you can see nothing's in here. I'm going to start from scratch. So I'm going to go ahead and put the numbers into this. So 12, enter, 20, enter, 30, enter, 32, enter, 36, enter. So those are my 5 data points. And those data points allow me to be able to do several different things in the statistics section. So I'm going to hit the stat key now that I have all 5 data points in. And I'm going to go 1 column over here to calc. And you should be doing this with me, right? Over to calc. And this top thing says 1 var stats. So that means 1 variable stats. And this is just one set of variables. Oops, sorry. One set of variables. And again, I didn't even tell you what those numbers meant. They're just numbers. Okay. Maybe it's you and your significant other went out to eat at a restaurant, and you spent $12 here, $20, $30, $32, and $36 for the 2 of you on 5 different occasions. Okay. So maybe that's what that is. So in that case, the average meant that you typically would spend about $26. The median is 30, so that means that if you got rid of your really expensive meals and your really cheap meals, the one that was in the middle was 30. We didn't have a mode, which means that we did not repeat the same price for any of the meals. And the range is $24. Well, that probably means that maybe this one was Burger King, and maybe this one was a little bit nicer. Maybe you went to Applebee's and you just got burgers and a drink or something. Okay? So it's not like there's any Zazios or anything like that here, or Webster's downtown, where you're spending $100 or something on it. Okay? So that's the range. So standard deviation in this case would mean that the spread out of these things is about 8.76, where that's a pretty good variety in terms of dollar amounts between these different things. Okay? So back to your calculator now. 1 var stats is what we're looking for. So I'm going to hit enter. It's going to ask me, and this is on the newer calculators. It's not on the older calculators. It's just going to say enter. So list, frequency list is something that I could do later on. I'm not going to do it in this course. And then I can just hit calculate. So on the older calculators, all you're going to do is hit enter, and look what it gives you. So you can see that that top number says X bar is 26. Well, look at that. That's what our X bar was, 26. You can see that there's our little standard deviation of 8.76 and 8.76. So all of this stuff that we just did by hand, this calculator can do it for us. That's kind of nice. Tells us that we're 5 numbers. The lowest number was 12. The median was 30. The highest number was 36. If I take 36 minus 12, you can see that I can get the range just from this stuff is 24. The only thing it doesn't tell me is it doesn't tell me a mode on this set of data. It does tell me a Q1 and a Q3. And a Q1 and a Q3 are like the middles of the bottom half of data and the middles of the upper half of data, or the first quartile and the third quartile. And I'll talk about that later on in one of the other videos. Okay, so again, I can get all of this information from right here. And how did I get that? So I'm going to go one more time through it just to make sure. So we go to stats, we go to edit, we put our data in, 1, 2, 3, 4, 5, and then we go stat, over to calc, 1 variable statistics. We choose L1, and again, we don't have to choose that. It automatically chooses it in the old calculators. If I had it in a different data set, I would need to choose a different thing. So watch, I'm going to choose L2 right now. You can see the numbers 1, 2, 3, 4, 5, and 6 have L1, L2, L3, L4, L5, L6. Those are where the different lists come. So I'm going to go ahead and choose L2 for my data set, and I'm going to go to calculate and enter, and it says, of course, hey, this doesn't work. There's an error here. Well, why? Well, if I go to it, if I look at my stats and edit, there's no data in L2, so of course it can't do that. So I'm just going to throw this in here so you guys can see it. Let's put in 8, 8, 8, 8, and 8. So maybe you're a creature of habit. You went to a restaurant, you get the same thing every single time. You spend $8 every single time. That's all you got. So now if I go here, stat calc, one variable stats, enter. I am going to use L2. I am going to hit calculate. It should do it for me now. And you can see that the mean is 8. And the minimum's 8, and Q1's 8, and all of that. But look at my standard deviation. My standard deviation is 0. That means there is no spread whatsoever. There's no spread in the data. Every number was the same. So if this is measuring spread, you can see that that doesn't change much. Good deal? Okay. So hopefully this was a great help for you, at least a benefit for the first start. Again, this is Mr. Bell's Introduction to Statistics on Mean, Median, Mode, Range, and Standard Deviation. Make sure you're comfortable finding it by hand and using your graphing calculator for it. We'll talk to you later. Out.